Welcome to the third lecture in the summer assignment, topic 1. So this is topic 1, part 3, which is all about significant figures. Again, as usual, and this should be the pattern that you're forming, you should have completed already in your learning target notebook the learning targets related to this topic of significant figures, and you should have a good foundation. You should have hopefully left space because you're going to do some more drawing. I'm going to do the first 2 of these with you now, but then you should go back and draw some more, and you will have some practice problems related to this. So if you haven't yet done this, stop the video and then restart it. All right, so as long as you've made your own notes, you're ready to go. Otherwise, stop the video, go back, and make your learning targets first. So remember that significant figures come from estimating measurements. And our significant figures estimation rules are that you should estimate once and only once. You have to estimate once when you're measuring with things that are non-digital. You should remember that digital equipment estimates for you. So like our balances that you've been using go to 2 decimal places, so maybe 4.53 grams is the mass of something, then that 3 would be the estimated digit, which means that it's falling somewhere, according to the balance, between 4.5 and 4.6, but slightly closer to 4.5. Okay, so when you're using digital equipment, the last estimate is your last digit is your estimate. Your estimate and the balance estimates is the last significant digit of your measurement. So it's really important that you remember to estimate. So from your learning targets then, I asked you to draw so that you can practice estimating. So the first one that I wanted you to draw was a 600 milliliter beaker marked to only the hundreds. So that's going to look something like this. So if you need to stop the video to draw, then go ahead and draw the beaker. And what's going to happen is I just want you to fill it with some random amount of liquid. So I'm going to come in and fill it maybe with this much liquid. And we will fill it up so that our, so that our liquid is in the beaker. Okay? So what this does now is gives me an opportunity to estimate what's going on. And I can see always in the liquid estimate at the bottom of the meniscus. And I can see here that my bottom of the meniscus is somewhere between 300 and 400 milliliters. All right. I have to make a decision where, and I'm only allowed to estimate once, which means that after I'm done estimating, maybe this is a little more than halfway. So I'm going to say 300 and I'd like to say 355, but I don't think I can do that because I don't even know that it's 350. So the 5 is the estimate, and I'm going to have to call it 350 milliliters. Okay, so an appropriate measure when this is marked to the hundreds would be estimated to the tens, and that means that this 0 is not significant. Okay, so I would have 2 significant digits. Let's do the same thing, this time with a 100 milliliter graduated cylinder marked with 10, 20, 30, and 9 unnumbered marks in between. This is what our graduated cylinders look like usually from the 100 milliliter standpoint. So let's come in and I'm going to make this really skinny. So let's come in and say I have the meniscus of my liquid falls, oh, I'm a really bad artist, you're going to discover this as the year goes on, falls right there. Okay, so I see the bottom of the meniscus is like right there. All right, so if this is marked to the whole numbers, I know that this is 70, 71, 72, 73, 74, 75, 76, 77. It's somewhere between 77 and 78 milliliters. So I have to decide where, and I think it's closer to 77. So I'm going to say maybe 77.3 milliliters. And in this case, this 0.3 is the estimate. Okay, so I have 3 significant digits. If you're marked to the ones, you have to estimate the tenths. All right, so now after you can stop the video now if you'd like, or you can go back at the end. You should be drawing and estimating these 4 things so that you have them there. Notice that these 2 are electronic, so you're just going to draw what the screen would show. And picture that the digit that's estimated is already the digit showing. So think about what that looks like. Okay. Reports to means this is what the screen says. Okay. So that's your foundation of what significant figures are. College Board gives you a slight amount of leeway with significant figures, but unfortunately, if you're wrong by more than 1 either direction, in other words, if you're supposed to have 2 sig figs and you have 4, 3 is okay, but 4 would not be if it's supposed to be 2 sig figs. Then they'll take a point away that you never earned. They don't give you points for sig figs. They only take them away in a question if your sig figs are wrong. So you really want to try to be right. So remember that sig figs are only for measurements, not for counts, not for mathematical definitions like adding or subtracting, or like dividing by 3 to take an average of 3 numbers, things like that, not by multiplying by 100 to make it a percent. Stuff like that is a mathematical definition, okay? So, and sig figs don't work for counts. So counting is, you have to think about what you're counting, okay? You have to know about those zeros. Non-zero numbers are always significant, but you need to know about the zeros. So before a number to the left of any non-zero numbers is never significant. It doesn't matter whether there's a decimal or not. Before the number is not significant. After non-zero numbers to the right, if there's a decimal anywhere in the number, then those digits, zeros to the right of all your non-zero digits, are significant. But if there's not a decimal in the number anywhere, and it has to be a written decimal, not implied, then they're not significant. And then finally, zeros between numbers, non-zero numbers, are always significant. So let's practice. I'm going to do a few for you here, and then you can practice in the practice problems. So we're going to underline the zeros that are significant and determine the total number of sig figs. So I look at this as now 31.070. I see a decimal in this number, which means that the 0 at the end to the right is significant, and zeros in the middle are always significant. So this is a total of 5 sig figs. All right. I see a middle 0 in this 0.06060. And I see a right after the decimal, and there's a decimal in the number, is after the numbers. I call those after-afters. And so those are significant, but these two are not, which gives me a total of only 4 sig figs in that number, okay? 850 degrees Celsius with a decimal. So this is a 0 that's after non-zero numbers, and there's a decimal in the number. That means it is significant, which means all 3 are significant. Okay, so stop the video and try these 3. Write them down first: 200.0 milliliters and 0.000005039 meters and 0.000401 liters. You try first and then restart the video. Okay, so these are all after the number and there is a decimal in there, so this is 4. And if I want to put that in exponential notation, it would be 2.000, those zeros stay, times 10 to the second, okay? These zeros in the front are never significant, so this is only 2, and it's 3.9 times 10 to the negative 1, 2, 3, 4, 5, 6 meters. Okay, sorry, I should add the units. And then these are zeros in the front, so they're not significant, but this 0 in the middle is. And so this is 3 significant figures, and it would be 4.01 times 10 to the negative 1, 2, 3 fourths. 1, 2, wait, let me count again. 1, 2, 3 fourths, okay? And liters. So hopefully you were correct. Practice some more in the practice problems. Finally, the last thing I want to talk about here is mathematical operations with sig figs. There are 2 different rules for addition and subtraction and for multiplication and division. So when you mix operations, you have to pay attention to where you would round but not round, and I'll show you what I mean by that. Remember that addition and subtraction, you care about location of the last significant digit, and you're only as good as the one that's the farthest to the left in your given. And for multiplication and division, you're counting significant figures, and you're keeping the same as the one with the fewest significant figures, okay? And then finally, logarithms I'll come back and look at with you in just a second. We'll do an example together, and I'll show you that. But in logarithms, the places in the decimal after you take the logarithm are your significant digits. And so your measured value has sig figs, and then your logarithm, those sig figs are after the decimal, and everything before doesn't really count as a sig fig but has to stay. Okay, so that's confusing. You might have to come back and listen to that part again. All right, so let's do this math quickly and see what happens. Since I see that this is an addition and multiplication and division problem, I'm going to do the addition first and see that this is 63.05. But the addition rule is places after the decimal, and this one has only one, whereas this one has two. So I'm only good to one place after the decimal. So technically I would have to round that to the 10th place. I'm going to wait till I'm all done to round, but I need to know where that will be. So I have to be really careful, because when I do my multiplication and division, now I'm worried about total sig figs. Okay, so now I'm going to go ahead and divide that by 73.55, and these are milliliters, seconds, and multiply, because this is dividing by a fraction, multiply by 60 seconds over 1 minute. Okay, so when I do that, you need to know that this is an exact equality, which means it has unlimited significant figures. So I'm not worried about the sig figs in that, but I am worried about the sig figs when I divide. So I see that 63.05 to the 10th place is only 3, and the bottom 73.55 is 4 sig figs. So I'm going to finally round, when I'm all done with my math, to 3, because it's the fewest. So I got 51.5434 more numbers, which is going to be 51.4. And the units that will be left will be, let's see, seconds cancel, milliliters per minute. So the final answer would be 51.4. Notice that I didn't really round. I used my number, but I figured out where I would round to. So maybe now you try this one. Do the same thing and see what you get. Stop the video and start it again. Okay, so when I did this, I did the subtraction first, which this all added up to, or subtracted out to, 119.38. These are both good to two places after the decimal, so all of those digits are significant, which means that the top has 5 sig figs, whereas the denominator has 3. 0 is significant, and 3 and 4. So I'm going to have to round to 3 when I'm finished. The answer was 0.822204, rounded to 3 significant figures. Oh, sorry. Undo. And undo again. Rounded to 3 significant figures is 0.822, and the units will be, grams per centimeter cubed. Okay? Finally, let's do a logarithmic example. We do pH all the time later in the year, so I just want to introduce you to it. If this is a measured value, this has 2 significant figures. Because it's in scientific notation, everything at the beginning has 2 sig figs. If pH equals the negative log of H3O plus concentration, pH would equal the negative log of 5.4 times 10 to the negative 4th. And when I punch that in my calculator, I use the negative key, not the subtraction key, but the negative key is a log key, and then 5.4, so it would read negative log 5.4, then I push second comma, which reads E, and then I push the negative sign and 4. This is what my calculator would show, okay? And then I hit enter, and it reads for me, I don't know, I didn't punch it. Sorry, I thought I was ready for you. The negative log of 5.4 times 10 to the negative 4th is 3.2676, some more numbers. I need to notice that I have 2 significant figures, and in here, the only things that are significant are the ones after the decimal. I keep everything ahead of the decimal, but I stop after as my 2 significant figures. So these 2 digits are my 2 sig figs. So if the pH is 2 significant figures, it's going to be 3.27. Okay? If I were going backwards and doing the antilog, then I would have to remember that these mean only 2 sig figs, not 3. Even though it looks like 3, this is only 2. And that can be confusing, so we'll work with it more later in the year. Thanks for watching.